Hello, students. Our today's topic is work done by the constant force. Let's understand what is a constant force. The force is said to be constant force if it produces constant acceleration. For example, the force of gravity or any finite force. To understand it more, let's see few examples. In this picture, a girl shoveling snow. Here, a man is pushing a stall vehicle. A man lifting a heavy load. A player stopping a ball. In all these examples, the applied force and displacement are finite. Therefore, applied force can assume as a constant force. Work done by the constant force is defined as displacement of an object in the direction of the force. Formula: work is equal to applied force into displacement in the direction of the force. This formula is applicable to determine work by the force which produces displacement in its direction. Now, let's take an example in which force and displacement are not in same direction. In this picture, a girl shoveling snow. This is the direction of applied force. This is the direction of a displacement. Force and displacement are not in same direction but makes an angle theta. To determine work in this case, redraw the vectors force and displacement. Draw the projection of the force over displacement S. F cos theta is the component of the force in the direction of displacement. Now, the component of the force and displacement both are in same direction. Therefore, we can use the work formula over here. Work done by the component F cos theta in the direction of a displacement is given as W equal to F cos theta into S. This is the work done by the component of the force in the direction of displacement. Modified definition of work done by a constant force is the product of the displacement of the object and the component of the constant force which is parallel to the direction of displacement. W is equal to F cos theta into S, where F cos theta is the component of the force in the direction of a displacement S. Work is equal to F bar dot S bar. That is, work done is the dot product of a vectors force and displacement. Therefore, work is a scalar quantity. SI unit of the work is joule. Positive work. As shown in figure, a block of mass 5 kg slides down an incline of inclination 30 degree and length 10 meter. Find the work done by the force of gravity when the block reaches from highest point to the lowest point. In this example, the force acting on the block is the gravitational force, which is one of the example of the constant force. In this figure, angle between an incline and height of inclination is 90 minus theta. Let's see the forces acting on a block. N is the normal reaction acts perpendicular to the surface of the block. mg is the weight of the block acts vertically downwards. Resolve mg. Normal reaction get balanced by the component mg sine 90 minus theta. Therefore, according to Newton's first law, the unbalanced component mg cos 90 minus theta produces displacement of the block from the highest point to the lowest point. The component of force mg cos 90 minus theta displaces the box in the direction of displacement. Cos 90 minus theta equal to sin theta. Formula W is equal to mg sin theta into S. Given mass of the block is equal to 5 kg. Displacement S is equal to 10 meter. Angle of inclination is equal to 30 degree. Gravitational acceleration g is equal to 9.8 meter per second square. All the given values are in same unit. Substitute all the values in the formula. After solving, we have W equal to 245 joule. A work done is said to be positive when the force and displacement are in same direction. Negative work. An ice skater slides to stop by pushing her blade against the ice. The ice exerts a constant force of 95 Newton on the skater, and skater stop in 1.2 meter. The angle between the force and the skater's direction is 120 degree. Calculate work done on the skater by the ice. This is the direction of a force exerted by the ice on a skater, which is 95 Newton. This is the direction of a displacement, which is equal to 1.2 meter. Angle between the force and displacement is 120 degree. Redraw the vectors. To calculate work, extrapolate displacement S. Draw projection of a force over displacement. F cos 180 minus theta is the component of the force. The component of the force, F cos 180 minus theta, and the displacement are in opposite direction. Cos 180 minus theta is equal to minus of cos theta. Cos 180 minus 120 is equal to minus of cos 60. Work is equal to force into cos theta into displacement S. Substitute values. Work is equal to minus 57 joule. A work done said to be negative when a force and displacement are in opposite direction. Zero work. Suppose a man keeps box and moves along horizontal direction with a constant velocity. Find the work done by man on the block during the motion. Vector force and displacement are perpendicular. Angle between them is 90 degree. Cos 90 is equal to 0. Work is equal to force into displacement into cos of 90. Work is equal to 0 joule. A work done said to be 0 when the force and displacement are perpendicular to each other. Few more examples of the zero work. The boy pushes the wall. Displacement of the wall is 0. Therefore, work done by the boy is also 0. A standing girl. Displacement of the girl is 0. Work done by the girl is 0. A geostationary satellite revolves around the Earth. The period of a revolution is a 24 hours. After 24 hours, the initial and the final position of the satellite is same. Therefore, displacement of the satellite is 0. Hence, work done is 0. Exercise. A 5 kg box is pulled across a horizontal floor by applying horizontal force of a 60 Newton, reduces displacement 10 meter. Frictional force offering resistance of a 10 Newton to the motion. Fn is the normal force. Fg is the gravitational force acts on the box. Calculate work done in each case with the help of this table. Hope you understand the concept. Thank you.